Okay, yeah, so let's talk about these. Now, actually, most of them come from that, what would we call it, the procedural review. And so a lot of them are just going to be ones we'll look at and get pretty quickly. All right, so the first one, enter the number corresponding to the easiest and most efficient way of solving this. Now, these kind are super easy, but a lot of people are missing
Factor.
why. It's factor, yeah.
That's what I missed.
If we look at this problem, look here, we've got 2x squared minus 10x equals 0. Now, you don't have to do the problem for the procedural review, but you got to see that this is how you would do the problem. Look, now, whenever I want you to see something here, I have two terms, and in each of my terms, I have a variable. That is just screaming out for you to factor. Okay, let's have all distractions need to be away. Phones, everything in your pocket, please. So that's telling me if I've got x's in both of these, then all I've got to do is factor out that x. And while I'm at it, I can take a 2 out, right? So if I take out a 2x, what am I left with? From the first term, what am I left with if I divide 2x? X, right? Okay, because 2x times x is 2x squared. What about the second one? 5. Right? Factor. Now, solving this thing is an absolute piece of cake, because I've got my two factors. There's the first factor, there's the second factor. All I have to do with the zero product property is set those equal to 0 and solve. So either 2x equals 0 or x minus 5 equals 0. And this one's pretty simple. X equals 0 is the solution from that one. In fact, that's always going to be the case. When I can factor out a variable with or without a constant, if I can factor out a variable from each term, then I'm absolutely guaranteed that I'm going to end up getting x equals 0 for one of my solutions, for the reason that we just saw. Or, over here we get x equals 5, right? And so, clearly the way to do this, by far the easiest way to do this, is factor. Okay? Either of the other two, actually the first one wouldn't work, but quadratic formula would. It's just a lot harder. You have to go through that whole formula, right? And factoring, much easier. Questions on that?
No.
Okay? Okay, what about this guy?
Ooh, it's cute. That'd be quadratic.
Okay, are there any we can cancel out? Isolate x. Either of the bottom two are going to give you substantial credit, but what's the best one? Well, the question you have to ask yourself is, are there magic numbers? If there are magic numbers, then that tells us we should factor. If there aren't, we go to quadratic formula, right? So are there numbers that multiply to negative 10 and add to negative 9?
Yeah.
What are they? Yeah, so it'd be negative 10, positive 1, right? So this thing would factor into x minus 10 times x plus 1, and that's super easy to solve, right? Just set the factors equal to 0 and solve,
So factor.
right? So it would be factor. Is slightly better. And those of you who got that one wrong, don't you get like 9.5 out of 10 on that one or something?
Yeah, I'm still doing 100 on
Exactly, but you want to get 10 out of 10. And so factoring, and the reason I gave you so much credit is quadratic formula is almost as easy in this case, but it's just not quite, right? It would work, but it's better to factor.
I say that's just an opinion.
Just an opinion? Okay. Now what about this one?
Isolate.
Isolate x, good. Now it may not look like that at first, and what's our rule? What I've said this a million times up here. If you can point to a single x, then you can isolate it. Well, I can't point to a single x yet, but I could very easily make it that way, couldn't I? In one step, I could get it so I could point to a single x, right? If I take this stuff up here, and all I have to do is what? Subtract 10x squared from both sides? And if I do that, I'm going to get 19x squared minus 18 equals 25. Agreed?
Yeah.
And now I can point to a single x, and so that's telling me isolate, right? What would the steps be to isolate it? First I would
Add 18.
add 18. Good, that would get rid of this guy. Then I would divide by 19, and then square root, and I'd have it, right? Good. All right. You guys get it. This is great. Okay, what about here?
Factor. No, just kidding.
No, that's
Isolate.
quadratic.
Isolate. Absolutely. We're going to
Oh.
isolate because
Stupid.
I can point to a single x, which means isolate. Just reverse order of operations and isolate. Right. Okay, what about this one?
That one's easy.
Are there any we can cancel out?
Easily.
Isolate.
Can't isolate because I've got x squareds and x's, right?
Quadratic.
So it's either factor or quadratic. Are there magic numbers? Are there two numbers that multiply to positive 12 and add to 4?
No.
No, there are not. So this one is not factor. Must be used quadratic formula. Right? Question?
So,
Yeah.
if the unmagic numbers factor?
Then you should factor. Yeah. If I can find magic numbers, then it's easier to factor.
What if it took forever to find the magic numbers? And it's like, should just
Well, okay,
use the
now
quadratic
it
formula.
won't because now it's a good question because we're going to see a couple examples coming up where we've got situations where I have a number in front of x squared. That makes it harder to find the magic numbers, doesn't it?
Yeah.
Don't bother. If there's a number in front of x squared that I can't divide away, right? If it's a number in front of x squared that doesn't divide into each term, so I can't divide it away from both sides, I'm stuck with an a that's not 1, then we absolutely don't want to mess with that, at least in my opinion, and we just quadratic formula the thing,
So it's
right?
multiply to 12 out of 4?
Yep.
What if the number does divide to those?
We'll see one like that. Then we'll just,
Maybe there's like a 2 in front of that next to it.
then we could divide both sides by 2. And I've got an example like that that we'll see, yeah. What about this guy? What would you do first? And there's a different kind of problem.
Oh.
So it's not asking for a strategy. It's one of those pull-down menus where you're going to do
Add
what?
4. Add negative 4.
Add negative 4.
Good. You're going to add negative 4 because our strategy here is to isolate x, isn't it? Right.
Buried.
Our goal is we got a single x right there that we can isolate. And the way we would isolate it is first subtract 4, then divide by 2, etc. But the first thing we would do is subtract 4. Right? So here's, whoops, oh. I get so excited up here. I can't even hang on to
It's
this.
breaking. You get one of those like V, like that one with V, you know, that's what I stress it.
That's what I need, exactly. Exactly. Yeah, I might need one of those. Okay, so I could add to both sides, because there is no option for subtracting. So I add to both sides the term in this case, it's not plural, the term negative 4, right?
Let's see that.
Sweet.
Check?
Check.
All right.
Mate.
Okay, what about this one?
Close one.
Good. Now this one's a little different, isn't it? This time, that last one, were we isolating? I can't remember.
Yeah.
Yeah, we were. No, it's very similar. You're right. So we're trying to isolate x, just like before. There's my x. To get it by itself, first I add 1, then I divide by 3, then I square root. But first, I add 1. Right?
Mexican dinner.
Good? All right. Okay, what about this guy? Now, this one is a little bit different.
Add negative 7. Or add 7.
Okay, good. Now, this time, are we trying to isolate? No, we're not. This time we want to get the whole thing set equal to 0 so we can put it into standard form. Now once we get it in standard form, we can sort of reevaluate. But if I added 7 to both sides, would you agree that I'm just going to get 2x squared minus 4x plus 10 equals 0? Right? And then here's one like Nick was asking about. Now I could divide everything through by 2, couldn't I? Right? If I divide, because 2 goes into all 3 of those?
So you'd only divide by 2 if it goes into all 3?
Exactly, if it goes into all 3 of them. So I could divide both sides by 2. 0 divided by 2 is still 0. Now I got to divide each term separately. So 2 divided by 2 is 1. Negative 4 divided by 2 is minus 2. Whoops, not squared. Right? And 10 divided by 2 is 5. And then we'd get to the step where now we ask ourselves, do we factor or do we quadratic formula? And there are not two numbers that multiply to positive 5 and add to negative 2, so now we would just throw it in the quadratic formula, right? But this question isn't asking for all that stuff. All it's asking for is what's our first step? Well, add 7 to both sides. Yes, sir.
Okay, so you're not supposed to be doing math online, right?
Right.
And so when you see the equation 2x squared minus 4x plus 10, would you just say, oh, I should factor it because you can divide 2 and they're mathematical numbers?
Okay, so you mean if you started here, you're saying?
Yeah.
Yeah.
If you
So
started
then you would divide by 2. Divide both sides by 2, because the first thing you'd want to do to make this problem easier is pare it down, trim it down.
No. Like those other questions where it's like, one is isolate x, use the quadratic formula, or factor.
Oh,
Like, when you see that equation, would we just factor, use the quadratic formula?
oh, I got you. That's a good one.
Like, should we try to do the math and figure out the automatic numbers?
I-
We're not supposed to do the math.
Okay, you're right. You're right. I honestly didn't give you any like that, so you won't have to fight that battle. But it's a good question. Probably what you would do is you would divide both sides by 2 first, and then evaluate what you're doing.
What if you couldn't divide by 2? What if it was like?
Then you would
2x
definitely
squared?
quadratic formula. So if that was like 2x squared minus 4x plus 9, you don't want to do that a times c then split b thing, do you?
Well, what if it was like on this one? What would you do first?
You'd still have to get it equal to 0 to use the quadratic formula. So you'd still add 7. Does that make sense?
Yeah.
Because you got to get it into standard form. I guess, based on your questions, I think the thing I need to tell you here that I need you to recognize is that because I have x squareds and x's there, I'm not going to be isolating x, right? Because I'm not isolating x, I need to get a 0 over there, right? I'm not pushing stuff to the right side now. I'm pushing stuff to the left side to get it into standard form. See the difference? Whereas in the last example, actually the last 2 examples, it was a little different. In the last 2 examples, I could isolate x, and so now I'm just trying to get x by itself. So I'm pushing stuff to the right, away from the x. Make sense to isolate it?
Yes.
But in this case, I can't. I can't isolate, so I got to get the thing in standard form. Okay? Okay, what about this one? Thank you.
Add 3x per 3.
I'll pass these out. Say it again.
Add 3x plus 3.
Yeah, good. Okay, because once again, I can't isolate x here, can I? I've got x squareds and x's, so I got to get the whole thing equal to 0. So to get it equal to 0, I have to add 3x plus 3 to both sides, right? Okay? All right, so oops. Next one, did I mix them up? I didn't look at who I was giving them to. So what about this one?
Divide by 9.
Make sense?
Yeah.
Okay, because we're isolating x, right? Okay. So I'm going to divide both sides by the factor 9. Okay? Yeah, you bet. What about this one? Here's one like we just talked about. Divide by 6. Divide by 6.
Divide by 3.
Is there a number that goes into 12, 6, and 9?
3.
3. Right? So why not divide both sides by 3? And I'm still probably going to have to use quadratic formula this time, right? But at least I'm putting smaller numbers into the quadratic formula, which makes it easier. Okay? Questions?
No.
Okay. Okay, what about this one?
Divide by 5.
Divide by 5?
Yeah.
Okay. Everybody see that?
Eraser.
I'm isolating x. Okay. How about here? Hang on.
No.
Oh, man.
What am I doing here? Factor. Yeah, because look at that. I got 2 terms. I got x's in both. What am I going to divide away from each term?
What?
This is one of those. This is how we started the whole day here today. We had one like this, right? If I've got 4x squared minus 3x equals 0, what do I factor out?
4.
Well, no number.
X.
X.
Squared.
Right? But I can take an x out. These are your friends. These are the easiest ones you can do. Because I can factor an x out.
Isolate X is the easiest.
No, because I got x's in both terms. I got x squareds and x's. I can't isolate it.
Isolating x is a lot easier than factoring.
If you can do it.
So you can only factor an X if there's not another number? Like if it's
Right,
X
exactly.
plus 3?
Exactly. I can only take out an x if each term has an x in it. Right?
Okay.
But because I have 2 terms and each of them have at least an x, one of them even has an x squared, I can divide or factor out or divide out an x from each term. Okay? See the benefit of that? Makes it very simple. And then now to solve this thing, there's one solution. Either x equals 0 or 4x minus 3 equals 0, which means x equals 3/4, right?
Yep.
Okay, so factoring makes that one very simple,
Easy skeezy.
right? Now, what about this guy? This one's a little bit.
Multiply by 9/4.
Okay, good, good. Now, I'm going to isolate x, right? Because there is a single x that I can point to, so I can isolate it. To get it by itself, first thing I have to do is get rid of that 4/9 that's being multiplied, right? And how do I get rid of a 4/9? Well, I multiply by the reciprocal. So,
Easy skeezy.
multiply both sides by the factor 9/4. Okay? Now, this is one that caused a few issues for people. Stare at this for a second. Can I isolate x here? No. Cannot isolate x, you're right. Okay, so what some people are tempted to do here, and I understand why, this isn't a bad answer, but there's a better one. Because I can't isolate x, we know that we're going to eventually have to get a 0 on this side. So a lot of people said add to both sides the term 1. And I understand why they did that. But there's something else going on here that we really need to take care of. What's so ugly about this problem? The fractions, yeah. Now, maybe it helps. It might be helpful to rewrite this thing without using fraction bars instead of slashes. So if I do that, I've got 3/2 x squared plus 2/3 x plus 3/4 equals 1. I don't want to have to be dealing with putting those fractions into the quadratic formula. My goodness, that would be terrible. Yeah.
What did you divide by 3?
Divide by 3. Well, I can't really divide by 3 because
What is it multiple?
I'm going to multiply, aren't I?
Yeah.
I want to clear the fractions here. But remember our strategy. To clear the fractions, I have to multiply both sides of the equation, distribute through on both sides, the least common denominator of all the denominators.
12.
So it'd be 12, wouldn't it? The smallest number that 2 and 3 and 4 all divide into is 12. And so what I'm going to do is I want to multiply 12 through both sides. Right? Yep.
That should be.
Oh, negative 1. Whoops.
Negative.
Negative. You're right. Okay, so now if I do that, let's just remind ourselves, not that we even have to do that for this particular problem, but let's just see this in action. If I distribute the 12 through, I'm either going to get 36 over 2, but even better, 12 over 2 reduces to 6 times 3 is 18 x squared, right?
Okay.
When we're reducing fractions, or clearing fractions, you might as well reduce before you multiply so you can deal with smaller numbers. Remember that trick. 12 over 3 is
36.
12 divided by 3 is 4 times 2, right? 12 divided by 4 is 3 times 3 plus 9. And then over here I just get negative 12. Now that's a ton easier to deal with, right? Now we could add 12 to both sides and go to town on this thing, right? Probably quadratic formula, okay? But we don't want to don't want to mess with those fractions. So the best thing we could do first here is clear the fractions by multiplying both sides by 12. Okay? Okay, how about this? Let's see. Well, I guess we see the answer there. Yeah, this is clearly a quadratic formula one. Because look, I've got a is 3, and I can't divide the 3 out on both sides by 3. I'm stuck with that a being 3. Having done it, I made you do it so you know the technique. It's no fun to do the a times c then split b stuff. So we'll avoid it like the plague when we can. We'll just quadratic formula.
Multiply by 4.
Yeah, good. And it might help once again to write this as a fraction bar. I would strongly encourage you to do that when you're writing this down in your notebook or on a piece of scratch paper when you're actually doing the work. Rewrite this whole thing as the quantity x plus 4 squared all divided by 4 equals 1. Now it's really obvious that we got to multiply by 4, isn't it? Right?
Yeah.
Because we're trying to isolate x here, right? Okay? All right, so I think we're getting close to... No, not quite. Okay, what are we going to do there? Are there magic numbers?
No.
I can't isolate x. So either I'm gonna factor this thing, if I can, or a quadratic formula, but there are not magic numbers. I don't have numbers that multiply to -8 and add to -5, and so therefore, quadratic formula. Okay. What about this one?
Square root.
Okay, good. Isolating x, I got a square root both sides.
Hate you.
Okay.
Hey.
How about, now, okay, this one, okay, this is different. This is from the, we switched gears. I probably should have put something in there to alert myself to this, but I know now from where these came from that we are now no longer on the procedural review. Now we're
That's
on
intercept.
the non-graphing calculator.
That's
No,
intercept.
it's just still.
Okay, this is a tricky one.
That's
Yeah, what is
intercept.
this one? Now,
Intercept.
if we look at the three forms, and I want you to tell me those real quick. 'Cause I want you gotta know these. If we're gonna do standard form,
It's not standard.
what's standard form? Y equals,
Y equals A.
Oh, can you put the brakes on really fast?
Yeah.
Plus B,
Yeah.
plus B.
I need to know this.
Plus.
I can't undo my.
okay, there's standard form, right? And notice now I wrote in red the A, B, and the C to remind you, those are the three parameters that we have to replace with numbers, right? If we want to write down a function in standard form, we got to put numbers in for A, B, and C. And we'll look at some ways we can do that with the graphing calculator and without here. Whoops, do that. Now we had vertex form.
Y equals A parentheses plus K.
Okay, so
X minus H.
good. Okay, so we plug in the numbers here. We have the same A as before, right?
H.
X minus H quantity squared plus K.
Yep.
H and K represent the X and Y coordinates of the vertex, right?
No.
A is just telling us, does the thing open up or down? Okay, and then, now intercepts form, this will help you with the problem we're about to do. Intercepts form really is the same thing as factored form. If it's factored, that's a much better way of saying it. I don't know why our book chooses intercepts. Well, I do, because they're the x-intercepts. But factored form is how we would normally refer to this. And so y equals A times
X minus P, X minus Q.
A, same A as before, times X minus P times X minus Q. So why is this intercepts form? The easiest way to see it is because it's factored, right? I've got it broken into a product of factors. So what are the, now it might help if you rewrote this thing a little bit too. See, we could write this as negative the quantity X minus 0, because isn't X the same as X minus 0
Wait,
times
what?
X minus 13?
Whoa,
How'd you get there?
didn't you just change that from vertex to
I
intercept?
guess, yeah.
No,
That
I
was-
just,
it was
no.
always-
It was
No.
always intercept,
It's intercept the whole time.
because there's no square root or plus K in there.
Right.
That could be plus
See,
0.
we don't have, this
They
is
would
not,
Put it up there.
did we see this? This is not vertex because I don't have a quantity being squared. It is just factored. In fact, this is very similar to the problem that we started off the whole day with, where we were able to factor out an x, right? I can factor out an x from each term, and I'm left with something like that. So
So
because
A
it's,
just means if it opens up or down.
Yep.
If there's a number there, what does that mean?
if there's, well, okay, so in this case, what's a?
-1.
-1, yeah,
Well, what if
exactly.
it was like -3, then what does that mean?
Then it would be -3 would be a.
No.
What does it mean though?
You mean what if there was,
When you
oh,
graph-
okay, it just means, well, it means the number that goes with, I see what you're saying, the number part of the A just tells you how skinny is the parabola. The bigger the number, the skinnier it is. But we don't really care about that, honestly. We just, mostly, we're just interested in sketching these things. And when you had to find the graphs of quadratics on your review assignment, all you were generally looking for was the vertex and whether it opened up or down, right? If you had that information, that was enough to pick it out.
Wait, the bigger the number, the skinnier it went?
Yeah, and then the bigger the number, the skinnier it is. But that's, we don't worry about that. If we really need that accurate a representation, we're going to graph it with a graphing calculator anyway, right? This is really just for sketching. Okay, questions on that one? Because it's factored, it's easy to recognize as being intercepts form, because those are the same thing. Okay. How about this one?
Vertex. I mean intercept.
Okay, clearly that's in intercepts form because it's factored.
Oh, yeah.
Everybody see that?
Yeah.
Okay. So here's the winner.
Again.
Okay, how about that one?
Standard.
Or standard T.
Standard form? Ax squared plus bx plus c, right?
Yeah, oh yeah.
Standard form. Okay, how about this one?
Oh, that's vertex.
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 So cool for being a sophomore, yeah, whatever.
Okay, so, all right, hey, I need, yeah, dial it in a little bit here, please. Okay, so what about this one here now? If we want to write this, it's currently in vertex form, right? If I want to write it in standard form, here's the thing to remember about this. Standard form is the same thing. They both start with S. Standard equals simplified. That's all it is. Standard equals simplified. And to simplify something, we just do normal order of operations, right? Top down, right? So if I want to simplify this, and a lot of people had trouble with this, I do want to go through this one. So then we've got 4 times x plus 3 quantity squared minus 8. So what's the first thing if we're working our way down that we got to do? It's normal order of operations. What comes first? Parentheses. So remember what that means. Inside the parentheses, can I simplify anything? No. X plus 3 don't combine. They're not like terms. So we can check that one off and move on. What's next? Exponents. Good. Now the exponent is right there, right? So before, the mistake people make, if they make a mistake on this one, it's almost always that they want to distribute that 4 to the x and the 3, but you can't do that because that's out of order. Distributing is multiplying, right? And so you can't multiply until after you've dealt with that exponent. And something squared just means that something times itself. So we have to FOIL out. What we're going to do here when we're dealing with the exponents, we're just going to take that part of the function and expand it into x plus 3 times x plus 3, right? So this becomes x plus 3 times x plus 3. Now I've still got the other stuff there. When I'm all done, I've got to multiply the 4 through and subtract the 8, but we're focused on this stuff. And so if I FOIL that out, what am I going to get? Well, x squared plus 3x plus 3x is plus 6x if I combine the O and the I, right? And then 3 times 3 is plus 9, right? And so now, yeah, good. Now we're to the point where, notice I put that in parentheses. That's important because this whole thing is still going to be multiplied by 4, so it needs to be a quantity in parentheses. Minus 8, and then now if I distribute the 4, I'm going to get 4x squared plus 24x plus 36 minus 8. So that was our multiplication, right? We distributed the 4. That's multiplication. The last step? Yeah, just add and subtract like terms. Well, there, 36 minus 8 is 28. So our final answer. That's it, right? And what are they asking about specifically here? They want to know the value of A. So what's the value of A? Well, it's going to be 4, right?
But if it was asking for the value of A, wouldn't it stay the same? So it's the same as last.
You're right. You're right. So Dally's onto something here. If you're smart enough to outsmart the question, I would strongly encourage you to do it because why not? And what she's seeing here, what she's seeing is that when she's looking ahead, you correct me if I'm wrong here, but what I think she's seeing is she knows that if I multiply x plus 3 times itself, that I'm going to get an x squared out of that, right? And that's the only x squared in the whole problem. And so regardless of what happens with all this other stuff, eventually when she distributes that 4, she knows that she's going to end up with a 4x squared and a bunch of other stuff, but we don't care about it. If we're just trying to find A, you can see that A is going to be 4, right? Now, if that doesn't make sense and you don't see that, that's okay. You can always just do the problem and find A. But she's right. Okay. What about this one? This time it wants you to find C. And I'm not going to do the problem because it's the same as the last one we did. But if we go back to the last one and we were trying to find C, it's a little harder to skip steps on that because there's a lot of stuff that goes into building the C. I had to FOIL this out to get the 9, I distributed the 4, and then I subtracted the 8, right? So that one's a little harder to outsmart that problem. You kind of almost have to just do that one if you're trying to find C. But if you're trying to find A, you can take a shortcut. All right. Okay, what are we doing here? This is, yeah, this one is graphing calculator question. Pretty sure. Gosh, I think it is. Yeah, it is. It was for sure?
I'm your dirty liar.
I don't know that this one was.
We can do it.
No, it's not.
Oh.
It's not. This one was one on the non-graphing. Okay, so if we want to solve for x here, and look what it says, find the greatest real solution or complex solution with the greatest imaginary coefficient. In other words, if it's a complex solution, the one with the plus sign instead of the minus sign, right? So what do we do here to solve for x? Okay, so I'm gonna write this thing down here. How about? What's gonna be our strategy here? Isolate, or what are we gonna do?
Yeah.
Well, maybe, but we can notice I do have two x squared terms. So even though I can't point to a single x yet, if I combine those like terms, I could, right? Those go away. 9x squared minus 6x squared is 3x squared. Okay, now, maybe we want to rethink things. Now we can point to a single x, right? It's right there. So what are we going to do?
Minus 18.
Good. Isolate. So subtract 18. So 3x squared equals what? Negative 7.
Divide by 3.
Divide by 3. And I get x squared equals negative 7/3. So now what?
You do the square root.
Okay, so x would equal square root.
Square root.
What'd I forget?
Plus or minus?
Plus or minus. The square root of negative, negative 7 divided by 3. And when I see a negative sign inside a radical, what's that telling me? Yeah, I'm going to break the negative out as an I, right? So that's going to look like x equals plus or minus I times the square root of 7/3. Which one do we want?
Plus.
The plus. And even though it gives you the option of entering this as a decimal, and yeah, the reason being because it wants the greatest. Whoops. It wants the greatest imaginary coefficient if it's got i's in it. So we'll take the plus. I would encourage you not to make this a decimal. Uh-oh, did we make a mistake?
Where'd you get 21?
Where did I get 21? Is that supposed to be a... What
We
happened?
failed. Let's go home.
What did we do?
Oh, maybe they times by 3 to get 21.
What the heck happened there?
Just saying.
Well, I'm not sure. I pulled this off of students. Okay, I know what happened here, I think. Okay, what happened is they had done it correctly, and then they entered another answer that was wrong, probably. But that's not quite the right answer, is it? Well, we would enter. So how would we enter this instead? If we want to enter this in Moodle.
S-Q-R-T.
Yeah, if that's
Wait,
the
so
answer box.
how come Moodle said that they were?
Well, I'm not sure. I'm not sure. I think it's probably a deal where they had it right and then they changed it, but that's why it stayed green. I don't know why they would have, but I just randomly picked one that was right. But these, I think these pretty much work. So I wouldn't. Here's what we would put in though. We would put I times squirt. Oh, I see what they did. No, they did it right. They just did some extra stuff. Never mind. What'd they do? They took the radical out of the bottom. They multiplied top and bottom. They were overachievers. They didn't have to do this. But what they said was I times the square root of 7 over the square root of 3. And they multiplied top and bottom by square root of 3.
I knew it.
So they got I times the square root of 21 over 3. Okay, I don't care if you do that. It didn't, and I want you to notice what the question says here. The question does not tell you to simplify the answer. And so I don't care if you do. And honestly, it's not a big deal if you do, because all I want is an exact answer here, right? So if we were to write this as I times squirt of 7/3, which gives us that, that's it. If I want to ever go back and make that into a decimal, all I have to do is put that into my calculator. Square root of 7/3, right? But that is an exact answer. Is it simplified? No, we don't care. We just want an exact answer that we could put in a calculator if we needed to. Okay, so that's fine. You may leave it like that, with the plus sign, which you wouldn't write, but we don't put a negative there, right? And that's fine. Or you can be an overachiever if you want to. I shouldn't say that. That's good to do. It's simple.
Whose title was that?
Either way. I don't remember.
Who was that?
I don't remember.
I'd remain.
You think so? Okay, how about this one? Find the greatest real or the complex with the greatest imaginary coefficient. What are we doing here? Okay.
Same thing, right?
No.
Why not?
Okay, so are we isolating or are we factoring or what are we doing?
You gotta
We're isolating.
isolate.
Okay, good. Now let me just say something about this one because there were some issues with this. Some people wanted to simplify this by squaring this whole thing out and distributing the 4, and it's going to work, but that's a lot of work. Look what's going to happen if we do that. I'm going to have to collect this thing into standard form on one side and either factor it or apply the quadratic formula, both of which are a little bit painful. Isolating it is very simple. The steps, there's only just a handful of steps. First, I do what?
Subtract 14.
Subtract 14, then I divide by 4, then I square root, then I subtract 4 or add -4. Done. 4 simple steps and it's done. Right? So let's do that. If I subtract 14 first, 4 times the quantity x plus 4 squared equals 15, right? Now what? Divide by 4. Right? So now I can square root. So x plus 4 equals plus or minus, good. Plus or minus the square root of 15/4. Now what is the square root of 4? It's the square root of 4. 2. So I could write that as the square root of 15 over 2, might as well.
Why
wouldn't
couldn't-
have to.
Why couldn't we do that for the last one?
Because the last one didn't have a perfect square on the bottom,
Oh.
right? It was a 3, so we just left it in there. But in this case, I could have made it the square root of 15/4, but why not break that into a 2? It's easy to do. And then last step, okay, and remember when I'm adding or subtracting a number, I always want to put it in front of the plus or minus. So I end up with my answer being x equals -4 plus or minus the square root of 15 over 2. And we want the plus because it wanted the greater of the 2, right? So how would we enter our answer? We would just say -4 plus square 15 divided by 2, right?
Wait,
Instead of the least or lowest or whatever, you just say negative.
Yep, we would have put a minus there. Okay?
how come for the last one we didn't just do that? Like, how come we put out 2 thingies and factored them?
Well, the last one was a little.
Try to get the standard form.
It was a little different problem on the last one. Remember, we had an I in it. If we look at this guy, right? On the last one, we had to collect the like terms first, subtract 18, divide. I mean, it was a little different process because we had different problems to start with.
I thought it was the one No.
Okay, very simple, very simple. These are not a big deal. If we're going to simplify this, 16 plus 6i minus the complex number 15 plus 14i, what's our strategy on these? if we're adding or subtracting, are we just collecting like terms?
Yeah.
Right? So I've got 16 minus 15 is 1. 6i minus 14i is, what is that? 6i minus 14i, negative 8i. There's my answer. Okay, and what do they want? They just want, look, and all they're asking for here is the value of the complex coefficient b. So what's b? Yeah, right?
Yeah.
Does that make sense? So if we're thinking of this in the form a plus bi, b is just a number in front of I, so that's going to be the negative 8, right? Okay. Questions?
No.
Okay.
Last one.
I think, yeah, we're getting close. Well, we won't even try to do the graphing calculator one today. We'll just stop at the end of the non-graphing. This is a lot of stuff. So same kind of deal here, only this time we're multiplying. Yeah, you had quite a bit of practice with this, but let's maybe take a quick look at one of these. So 5 plus 13i times 8 plus 11i. What do we do when we're multiplying complex numbers?
Distribute.
Yeah, distribute. So we're going to FOIL it out, right? So we get 5 times 8 is 40. I'm going to get plus. Outside's going to give me, so
55.
there's the F.
I.
55i. 5 times 11i.
Yes.
Plus, if I do the I, I'm going to get 8 times 13, which is 104
Yeah, I knew that.
I. And then for the last, I'm going to get 13i times 11i, which is 121 plus 26, so that's 137 I squared.
Which is this.
Oh, hang on, that's not right. That's not right. It's one. Messed that up. It's 133. 133. Yeah.
What? Boy, that's something wrong.
But I caught it. So what's the I squared equal to?
Foil.
-1.
-1. Perfect. And so remember our little trick. Whenever I get an I squared, all that's going to amount to is we're just going to change the sign of the coefficient. So it would become a negative, right? So what I really end up getting is, if I combine like terms, is 40 minus 133 plus 55i plus 104i, right? So what's that giving me? 40 minus 133, what is that? Negative 97?
Yeah. What are you talking about, dude? I do it.
Plus 159i. And we want A. So A is negative 97.
Yes.
Good?
Real fast. 1 minute. Tell us the answer to the pirate.
Oh, I don't have time. Oh, I screwed something up.
I've been
No, you didn't.
stressing out
No, you didn't.
forever.
What's the answer to the pirate?
Sleep at night, what is it?
How do I? No, that's terrible.
We messed up.
This was wrong. I messed this up.
Tell us the answer of the pirate. We can't sleep at night.
Oh, God.
Oh, that's 141. I got that so messed up. 143.
Why are you
Anyway,
13 times 11?
What's the answer of the pirate?
the answer to the pirate is